talking about solving one-step equations. And when you're solving an equation, the whole goal of that is to isolate the variable. So isolate just means get the variable by itself. So for example, if you're given an equation x plus 4 equals 6, you want to get x by itself to figure out what x equals in that equation. So in order to do this, we need to perform the inverse operation. Inverse just means opposite. So you're just trying to think of what would undo each of these operations. So for the inverse of addition, that would be subtraction. And therefore the inverse of subtraction would be addition. So in order to undo those, you do the opposite operation. The inverse of multiplication would be to divide, so division, and the inverse of division is multiplication. So you'll see what I'm talking about as we go through some examples here, but these are just some basic rules to keep in mind as you're going through this. So for our first example, we have b plus 14 equals 27. Remember, the goal is to isolate the variable, so we want to get this b, our variable, all by itself. So right now, what is happening to this variable? We're adding 14 to it, and it's supposed to equal 27. So I'm going to undo what I see here. So right now I'm adding 14. I'm going to do the opposite and subtract 14 on this side, as well as subtract 14 on the other side. As soon as I do one thing on one side of an equation, I need to do it on the other to keep it equal. So sometimes to remember that, I like to draw a line through our equal sign. So whenever I do one thing over here, I've got to do the same thing on that side. I'm going to draw a line to show that I'm ready for my next step. My b isn't being affected by anything here, but my positive 14 and minus 14 are opposite numbers, and opposites add up to 0. So really this is like b plus 0. And on this side I have 27 minus 14. That gets me 13. Now b plus 0, anything added to 0 is just itself, so b is going to equal 13. So I've gotten my variable by itself. So I've reached my goal of solving an equation, so this should be my answer. But in order to check it, all we have to do is say, okay, well this was my original equation. If I sub in for when b equals 13, because that's my answer, if I put 13 in where b is, I should get the same thing on both sides of my equation. 13 plus 14 is 27. So that is correct, 27 equals 27. So I'm going to circle this final answer. It is true. Now in example 2, we have negative 5 equals w minus 4. So in this case our variable is w, and it's being subtracted by 4. So we just need to do the inverse of that. So the inverse of subtraction is addition, so I'm going to add 4 to this side. But whenever you do one thing to one side of an equation, you need to do it on the other. So I'm going to add 4 over here as well. I'm going to draw a line to move on to my next step. I'm going to work from left to right. So I have negative 5 plus 4. When I add negative 5 and 4, I get negative 1. My equal sign comes down. W, there are no other w's to combine here, so I bring that down. Negative 4 plus 4, they're opposites, so they become 0. So if you want to write that that's plus 0, you can. And in that case, w plus 0 is just w, so negative 1 is equal to w, should be our final answer. But if we check it, let's just make sure. So we have negative 5 equals w minus 4 was our original problem. Negative 5 equals, I plug in negative 1 where w was, negative 1 minus 4. So negative 5 should equal this. So negative 1 minus 4 does equal negative 5. So we're correct, and this is our final answer for that equation. So now for our next example, it's a little bit different. We've got negative 7s equals 56. So the first thing I'm going to do is just draw our line through our equal sign to remind us whatever we do one side, we need to do on the other. So I have negative 7s. So negative 7 is my coefficient here. Remember, that just means negative 7 is being multiplied by s, so I'm going to rewrite it like that. So in order to get our variable s alone here, we need to do the inverse of multiplying by negative 7. So the inverse of multiplication is division, so I'm going to divide, and I'm going to divide by negative 7 because that's what was being multiplied. So we do the same on the other side. When I take negative 7 divided by negative 7, I get 1 times s, which equals 56 divided by negative 7, that's negative 8. 1 times s is just s, so s equals negative 8 should be our answer. Now we go back and we check. So we take our original equation and write it over here. We have negative 7 times s, so we're doing negative 7 times negative 8, and that should equal 56. 7 times 8 is 56, and a negative times a negative is a positive, so 56 equals 56 is correct, and this is our final answer. Now in our last example, we have r over 6 equals 3. Remember, whenever you see a fraction, we're just dividing. So really what I'm going to be doing here is undoing this division. So the opposite of division is multiplication. So I'm going to multiply by 6. Whatever I do on one side, I do on the other. So I multiply by 6 on the other side. So this becomes 6 times r over 6, which equals 3 times 6, which is 18. And now this looks like what we started with over here. 6 divided by 6 is just 1. That's 1 times r equals 18, which means r should equal 18. So let's go and check that. If I have r over 6 equals 3, if I plug in 18 where r is and I divide that by 6, 18 divided by 6 is 3, so 3 equals 3 is a true statement, and r equals 18 is our correct answer there. So you're always just looking to see how can you get that variable by itself and do the inverse operation to get you there. So there's some what ifs here. What do I do if the coefficient is a fraction? If that's the case, you need to multiply by its reciprocal. Now reciprocal, remember, if I had, that's an L. If I had 4/5, the reciprocal of that would be 5/4. So you just take the top and bottom, the numerator and denominator, and flip them so that they're reversed. So if I have 2/3 times b equals 18, my coefficient in this case is a fraction, so I need to multiply by the reciprocal. So the reciprocal of 2/3 is 3/2. I'm going to multiply by that, which means I need to do the same thing over here. So if I take 3 times 2, I get 6 over 2 times 3 is 6 times b equals 18 times 3 is 54 over 2. 6 divided by 6 is just 1, so 1 times b should equal half of 54 here, which is 27, and 1 times b is just b, so b equals 27. So if we go ahead and check that, 2/3 b equals 18. If I plug in 27 where b is, I would have to do the multiplication on top first, so 2 times 27 is 54. Divide that by 3, and 54 divided by 3 is 18. So we're good to go, and b equals 27. In this next example, example 6, we have 9 equals negative 3/5 times w. So in this case, our coefficient is negative 3/5. So the reciprocal of negative 3/5 is going to be negative 5/3. So that negative sign has to stay with this. Okay, so we just flip it, but it's still negative. So I'm going to be multiplying by negative 5/3 on both sides. And I'm just putting it in parentheses to keep track of that negative sign. So I'm going to work down from each side. So I have negative 5 times 9 is negative 45 over 3 equals negative 3 times negative 5 is 15 over 5 times 3, 15. Still times w there. That w just comes on down. So now I have negative 45 divided by 3, that's negative 15. And then this equals 15 divided by 15 is just 1. So that's 1 times w, which means negative 15 should be equal to w. So if we go ahead and check our work then, 9 equals negative 3/5 w. So 9 should equal negative 3/5 times negative 15 is what we got for w here. 9 equals negative 3 times negative 15 is 45 over 5. 9 equals 45 divided by 5 is 9, so that's true. And negative 15 equals w is the correct answer there. Now sometimes you might see some word problems where you're going to have to translate the numbers or translate the sentence into an equation before you can solve it. So in this case we have 60 less than some number is 40. So that turns into 60 less than is going to be subtracting 60 from some number. Well, we don't know that number, so we're going to call it x. And is just means equals, and that's going to equal 40. So you might be able to just see, oh, well, what am I going to have to put in for x to get 40? We just have to take the opposite operation of what's happening to x and solve for x. So right now x is being subtracted by 60, so I'm going to add 60. If I do something on one side, I need to do it to the other. X comes down. Negative 60 and positive 60 become 0, so that's nothing. And then 40 plus 60 gets me 100. So x should equal 100. Now if we check it, x minus 60 equals 40 was our original equation. I'm saying that 100 is equal to x, so I'm going to plug that in. And 100 minus 60 is 40, so 40 equals 40 is true, and x does equal 100, so that's a true statement. Now this one's a little bit different. It says a number, so we don't know that number, so we're going to call that x, divided by 6 is 1/2. So that just looks like this. Now we need to figure out, what does x need to equal here? So what is happening to x right now? It's being divided by 6. So we need to do the opposite of that, which would be multiplying by 6. And when I do that, 6x over 6 equals 6 over 2. Remember, when you take 6 divided by 6, that's just 1 times x. 6 divided by 2 is 3. 1 times x is x, so x should equal 3. As long as we check that, x over 6 equals 1/2. So if I put a 3 in where 6 is, 1/2. So 3/6 isn't a totally simplified fraction. If we simplify it, that becomes 1/2 equals 1/2. Or if you want to put it in the calculator, you would get 0.5 equals 0.5. So x equals 3 is a true statement there. Now in our last set of examples, we just have some word problems to write equations for and then solve. So this one says, Todd makes $550 a week at his job. The company gave Todd a raise and he will receive $634 a week. How much was Todd's raise? So we don't know what Todd's raise is equal to, so I'm going to say R equals Todd's raise because we're not sure how much that's equal to. He was making $550 every week. They're giving him some raise, so we're adding that to his amount that he's making per week. And now in total, he'll be making $634. So to figure out what R is, we need to do the opposite of what's happening to R. So we're adding 550 to R, which means we need to subtract 550 from both sides. When we subtract 550 over here, 550 minus 550 becomes 0, and we're just left with R. 634 minus 550 gets us 84. So that would mean that Todd's raise is $84. And you could go back and check that by plugging in 84 where R was. 550 plus 84 would get you 634. So that makes a true statement. Now in our second example here, the Bailey family planned a trip to the drive-in movie theater and 42 family members attended. If each car holds 6 people, how many cars will they need to bring? So we don't know how many cars we need. So I'm going to say C is equal to cars. So each car holds 6 people. So 6 people per car, we're going to multiply 6 people times the number of cars needed. And the total number of people we need is 42. So in order to figure out how many cars we need to get C all by itself. So the opposite of multiplication is division. So on both sides of this equation, I'm going to divide by 6. Remember, 6 divided by 6 is just equal to 1, so I have 1 times C. 42 divided by 6 is 7. 1 times C is just C, so C equals 7. That means that we need 7 cars are needed. And just to check that one quickly, we would say, well, 6 times 7 is 42, so that would be a true statement. If 6 people are in 7, if there's 7 cars have 6 people, we would have a total of 42 people.